Okay, notes 18, division of radicals and rationalization. So concept 1 is simplified form of a radical. So it says consider any radical expression in which the radicand is written as the product of prime factors. The expression is in simplified form if all of the following conditions are met. So first, the radicand has no factor raised to a power greater than or equal to the index. The radicand does not contain a fraction, and no radicals are in the denominator of a fraction. So we'll see more of this in our examples. Division property of radicals. It says let a and b represent real numbers such that the nth root of a and the nth root of b are both real. Then the nth root of a over b is equal to the nth root of a divided by the nth root of b, where b is not equal to 0 because we don't want to divide by 0. Okay, so in this first example here, we know by the properties of radicals that we could separate this into the square root of a to the 6th over the square root of b to the 4th, which is the same as saying, okay, well, we have the square root of a to the 6th. So if we wrote a 6 times, how many groups of 2 could we take out? So I'm going to write that down. Same with the b's on the bottom. Oops, I wrote one too many. Okay, so here, notice I can circle 3 groups of 2 for the a's and 2 groups of 2 for the b's. So what that tells us is that I actually have everything coming out of the radical and nothing left inside of the radical. So this is a cubed over b squared, and that's my answer. For the next part, we're going to do the same thing, but notice I now have a number in there. So I'm going to make sure I do the number as well. So this is the cube root of 81 times y to the 5th over the cube root of x cubed. I have to use the prime factor tree in order to simplify the cube root of 81. So 3 goes into 81 27 times, 3 goes into 27 9 times, and 3 goes into 9 3 times, which means I have a group of 3 because I am taking the cube root of a number, so I need a group of 3, which means when I write my answer, a 3 is going to be on the outside, and then on the inside is also going to be a 3. I'm leaving some space there because I still have to do the y's. So y to the 5th means I write y 5 times. I circle a group of 3. So notice I have one y coming out, and since there's 2 y's left over, this is y squared on the inside. And then on the bottom, I have the cube root and the cube. Since they're both the same, I know they cancel, so this is going to be over x, which means this is my answer. Okay, so for this one, just like we can give both the numerator and the denominator the radicals, we can also combine it into one. And the reason why this is a good idea is because notice they both have the same variable p. So I can rewrite this as the 4th root of 8p to the 7th over p cubed. Okay. By doing this, I can use my properties of exponents that say if I'm dividing the same base, that means I can subtract the exponents. So this is the same as saying the 4th root of 8p to the 4th. Okay. I can then rewrite this as the 4th root of 8 times the 4th root of p to the 4th. By doing that, I see the 4th root and the 4 cancel out. And then if I try my prime factor tree on the 8, notice when I do this, I do not end up with 4 2's, but instead just 3 2's, which means I can't simplify this further, which means my answer is just p 4th root of 8. Okay, next concept is rationalizing the denominator where there is only one term. So rationalizing the denominator means we need to remove the radical from the denominator. Okay, so in these first couple examples, we're going to work backwards. So this is saying, okay, we have the square root of a times the square root of blank is equal to a. Well, we know in order for this to cancel out, we need to have our nth root, so the number that typically goes here, cancel out with the exponent, the one that typically goes here. So let's say this question mark is a. That means I would have the square root of a times the square root of a, which is the same as saying the square root of a squared, which would cancel, and I would be left with a, which is what I wanted. But then for this one, since this is the cube root, that means I need 3 y's under that radical. So here I have 1 y, okay, which means this question mark is going to have to be 2 y's. So I would write that as y squared. So this is the cube root of y times the cube root of y squared, okay? This is equal to the cube root of y cubed, because if it's under the same radical, we can just multiply these together, which means we are adding the exponent. So 1 plus 2 gave us 3. By doing that, the cube root and the cube cancel, and we are just left with y, which is what we wanted. So the goal is for our index, or our nth root, to match our exponent of the radicand. Okay, so our root to match the exponent. So this one's a little tricky here because our end goal is to get 2z, which means this number right here is going to have to be multiplied by another number in order to get a perfect fourth root. Okay, and then this z here is only z cubed, and since this is the fourth root, we need another z. Okay, which means the question mark is going to have to be equal to something times z. Well, in order to find that number, we need to think, okay, if we were to take the fourth root of a number, what number would give us 2? So let's try 16. Okay, if I do the prime factor tree for 16, I get 2 and 8, then I get 2 and 4, and then I get 2 and 2. Notice I have 4 2's right here with nothing left over, which means the fourth root of 16 is 2. So since I need this to multiply to 16, I have 2 here, which means my missing value has to be 8. So what I have is the fourth root of 2z cubed times the fourth root of 8z, which is equal to the fourth root of 16z to the fourth, which is equal to the fourth root of 2 to the fourth power z to the fourth power. Okay? And we know that this is 2 to the fourth power based off of that prime factor tree over here, which means my fourth root is going to cancel with those exponents of 4, and I am left with 2z, which is the answer I wanted. Okay, for this one, I want to get rid of that cube root on the bottom. So what I need to do in order to rationalize this is to multiply this fraction by something that is going to end up canceling out the radical. And so what we're going to end up multiplying is whatever is going to make this be a cubed. Okay, which means we are going to take 5 over the cube root of a, and we are going to multiply both the top and the bottom by the cube root of a squared, which means we get 5 cube root of a squared over the cube root of a cubed. The cube root and the cube cancel, so we are left with 5 cube root of a squared over a. And that would be our answer. Okay, in this example, I'm going to take that cube root and I'm going to make sure I give it to, the square root, and make sure I give it to both y to the 7th and the 7. Okay, I can simplify y to the 7th, okay, by writing my 7 y's, circling groups of 2. And then I notice that this is y cubed square root of y over the square root of 7. I want to get rid of the square root of 7. So in order to do that, I need to make sure that this ends up being the square root of 7 squared. So in order to do that, I need to multiply both of them by the square root of 7. So this is y cubed square root of y times square root of 7 over the square root of 7 squared. Okay, which means these cancel out, and these ones I can combine under one radical. So this is y cubed square root of 7y over 7. That is my answer. Okay, so for this one, I'm going to do the same thing. I'm first going to check 25 and see if that is a perfect cube root. Well, 5 goes into 25 5 times, and notice that 25 is the same as saying 5 squared. So technically, I need this exponent to be a 3, and I need this exponent to be a 3. So that means I'm going to multiply both the top and bottom by the cube root of 5, because this one's missing a 5, and then x squared, because it's missing 2 x's. So the cube root of 5x squared, which gives me 15 cube root 5x squared over the cube root of 5 cubed x cubed, which these cancel out. And I'm left with 15 cube root of 5x squared over 5x. And then the 15 and the 5 can simplify by dividing them both by 5. And I get 3 cube root of 5x squared over x as my final answer. Okay, last concept is rationalizing the denominator with two terms. So we're going to use what is called a conjugate. And a conjugate means we are going to take the binomial on the denominator, change the sign, and multiply both numerator and denominator with the new binomial. So in other words, if I was looking at this example, here is my denominator, which means my conjugate is going to be 2 minus the square root of 6. So notice it was a plus, and I changed it to a minus. So I am going to take this, and I'm going to multiply both the top and the bottom by 2 minus the square root of 6. Okay. So on the top, I have negative 2 times 2 minus the square root of 6 over, and what happens here, since one is positive and one is negative, I know my middle terms are going to end up canceling out. So what I'm going to do is I'm going to focus on whichever binomial on the denominator has that negative, and I'm going to square both the first term and then the last term, and I'm always subtracting them. So this is 2 squared minus the square root of 6 squared. So for the top, I'm going to distribute the negative 2n. And so I get negative 4 plus 2 square roots of 6 over 2 squared is 4 minus square root of 6 squared is 6 And so this equals negative 4 plus 2 square roots of 6 over negative 2. And I can take all of these numbers, not including the radical, and I can divide them by negative 2. And I get 2 minus the square root of 6 over 1, which means I don't need to write that part. And so this is my answer, 2 minus the square root of 6. Okay, in this one, my conjugate would be the square root of x plus 7. I just changed that sign. And then I multiply. So this gives me 4 plus the square root of x times the square root of x plus 7 over the square root of x squared, that first term, minus 7 squared, that last term. So for the numerator, what I'm going to need to do is FOIL this to simplify. So I'm going to distribute the 4, and then I'm going to distribute the x squared. So I get 4 times the square root of x, and then 4 times 7, so 28. And then I get the square root of x times the square root of x, so that's the square root of x squared. And then the square root of x times 7, so plus 7 square roots of x. Over square root of x squared is x minus 49. So simplifying this further, I have 4 square roots of x and 7 square roots of x, which gives me 11 square roots of x, plus 28 plus x all over x minus 49. And this is my answer. Okay, in this last example, I'm going to multiply both the top and bottom by the conjugate of square root of 2 plus 4 times the square root of 5, both on the top and the bottom. So that means on the top, I have 3 square roots of 2 plus 2 square roots of 5 times the square root of 2 plus 4 square roots of 5 over the square root of 2 squared minus 4 square roots of 5 squared. The big difference here is since this term here, that 4 square roots of 5 squared, has a coefficient in front of the square root, we need to make sure that not only do we square the square root of 5, but we also square the 4. Okay, but before I do that, I'm going to go and I'm going to FOIL out to simplify my numerator. So on the top, I have 3 square roots of 2 times square roots of 2. So this is 3 square roots of 2 squared. And then 3 square roots of 2 times 4 square roots of 5. And then on the bottom with the purple arrows, I have 2 square roots of 5 times square roots of 2. So plus 2 square roots of 5 square roots of 2. And then lastly, I have 2 square roots of 5 times 4 square roots of 5. So this is going to become 8, because 2 times 4 is 8, times the square root of 5 squared. Okay, all over 2 minus 16 times 5. Okay, so simplifying everything, this is going to go away, and then this is going to go away. So I have 3 times 2 plus, I do 3 times 4 is 12, and then square root of 2 and square root of 5 is square root of 10, plus 2 square roots of 10, plus 8 times 5, all over 16 times 5, let me check off to the side, is 80. Okay, so 2 minus 80 is negative 78, so I have negative 78 on the bottom. And then I'm just simplifying this top, so 3 times 2 is 6, 8 times 5 is 40. These can combine to be 14 square roots of 10. So this is 46 plus 14 square roots of 10 over negative 78. And I can't simplify the square roots of 10 because that's just going to simplify to 2 times 5. And then it looks like I can divide everything by 2. So all of these terms on the outside, I can divide by 2. And I get 23 plus 7 square roots of 10 over, is that 39? Let me double check. Yes, negative 39. Okay, and that looks like that's as simplified as it can get. So that's going to be my answer.